Picture this. You're gazing up at the night sky, and suddenly, bam, a star explodes.
A star explodes with a brilliance that could rival an entire galaxy. It's incredible.
Yeah, and this actually happened back in 1885, when astronomers witnessed such an event in what they thought was just a fuzzy patch of light.
Turns out they were looking at something much grander. The Andromeda Galaxy, our closest galactic neighbor.
It's amazing to think that something so seemingly small could actually be an entire galaxy.
Really is.
Welcome to Cosmos in a Pod Space and Astronomy series, where we dive deep into these mind-boggling moments in space and explore the wonders they reveal.
Today we're taking a deep dive into the Andromeda Galaxy itself.
A swirling mass of a trillion stars, dust, and mysteries.
And it lies just 2.5 million light years away.
That's mind-bogglingly close in the grand scheme of the
It
universe.
really is. It's a galaxy that's teeming with activity.
What kind of activity?
Well, you've got stellar nurseries where new stars are constantly being born.
So the galaxy is alive with creation.
Exactly, and then you have black holes lurking in the shadows.
It's amazing how these incredible forces of creation and destruction exist side by side in the universe.
It is, and we even see hints of past galactic collisions that have shaped Andromeda's evolution.
So it's got a bit of a history, this Andromeda Galaxy. It's been through some stuff.
It definitely has.
Let's unpack this, starting with that 1885 supernova sighting that we talked about at the top of the show. That must have caused quite a stir in the astronomy world.
Oh, absolutely. Back then, astronomers were still debating whether those fuzzy patches of light in the sky, those nebulae, were just within our own galaxy or if they were something else entirely.
And the technology at the time, was that even good enough to tell the difference?
It wasn't. They just didn't have the tools to give them a definitive answer.
So then this supernova happens. How did that change things?
Well, imagine this. They observed this unbelievably bright explosion in what they thought was just a nebula.
Yeah, that would raise some questions for sure.
Yeah. Right, and the sheer power of this event suggested that it had to be much farther away than any known nebula in the Milky Way.
So it's like, hold on a second, this thing's way too bright to be just down the street.
Exactly. It sparked a ton of curiosity. It really did, and led to, well, decades of research, to be honest.
And then what happened?
It wasn't until the 1920s that astronomer Edwin Hubble used these more powerful telescopes, and he was able to confirm that Andromeda was indeed a separate galaxy, vastly larger and more distant than anyone had ever imagined.
Hubble, what a legend. So that's when the universe suddenly got a whole lot bigger.
It did. It really did.
So now we know that Andromeda is its own galaxy. What's it like?
Well, imagine a majestic spiral.
Okay.
A swirling disk of stars, gas, and dust, stretching over 150,000 light years across.
Wow, that's huge.
It really is, and it's similar in structure to our own Milky Way.
Oh, so it's like a sibling galaxy.
You could say that, but with some key differences.
Like what?
For example, the gaps between its spiral arms are much wider.
Wider gaps. Why is that?
It's still a bit of a mystery, to be honest, but it could be due to past interactions with other galaxies.
So Andromeda has a history, eh? It's been getting up to some mischief out there in the universe.
Definitely. And you know what's really interesting? One of the pieces of evidence that points to this, it's double nucleus.
Double nucleus. What's that?
At the heart of Andromeda, we see not one, but two bright regions, each just teeming with stars and activity.
Two nuclei. That's unusual, isn't it? What's
Yeah.
going on there?
Well, that's the question, isn't it? One theory is that Andromeda actually merged with another galaxy in the very distant past.
Okay, and so what happened?
And the core of that swallowed-up galaxy is now nestled right alongside Andromeda's own core.
So it's like a galactic souvenir of its turbulent past.
Exactly.
That's so cool.
But there's another theory as well
What's that?
that proposes that it's not actually two separate nuclei,
Okay, but what is it then?
but instead a really dense band of dust
Okay.
that's actually obscuring part of the central region and creating this illusion of two distinct cores.
So it's a cosmic game of hide and seek.
You could say that, yes.
How do scientists hope to figure out which theory is correct?
Well, they're using some pretty advanced telescopes, let me tell you, to study the motions of the stars and gas in that central region.
And what are they hoping to find?
By mapping those movements, they hope to get a clearer picture of what's really going on at Andromeda's core.
So it's like they're trying to see through the cosmic dust and get to the bottom of this mystery.
Exactly, that's what they're trying to do.
I know Andromeda has some pretty incredible stars within it, stars living out their lives in some pretty spectacular ways.
Absolutely. There are stellar nurseries, these vast clouds of gas and dust where new stars are constantly being born.
It's amazing how these cosmic nurseries are constantly churning out new stars, new possibilities.
It really is. And then you've got stars like AE Andromeda.
Okay, AE Andromeda, tell me about it.
It's a massive blue giant star.
A giant star. How giant are we talking?
It's about 700,000 times brighter than our sun.
Whoa, that's huge.
And astronomers think it's on the verge of exploding as a supernova.
Wait, so we might actually get to see a supernova in our lifetime?
Well, they estimate it'll happen within the next million years.
Oh, okay, so maybe not our lifetime, but still, that's relatively soon in the grand scheme of things.
It really is, and it's a reminder that galaxies are dynamic, ever-changing places. They're not just these static, beautiful pictures in the sky.
It's like they have a life cycle, they're born, they evolve, and sometimes they even die.
Exactly.
And their death can be just as spectacular as their birth.
Absolutely. Stars are born, they live out their lives, and they die in these spectacular explosions, scattering elements across space that eventually become part of new stars and planets.
Yeah.
This cycle has been playing out for billions of years.
It's just incredible, isn't it? This constant cycle of creation and destruction.
It is. It really is.
It makes you realize we're not just talking about static points of light here. We're talking about this living, breathing galaxy with a whole life cycle of its own.
Exactly. And Andromeda's story is far from over. It's still unfolding. It has all these fascinating features that we're just beginning to understand. For example, there's NGC 206.
NGC 206, tell me more about that.
It's this giant star cluster located near the edge of Andromeda's disk.
Okay, and what's so special about this star cluster?
It's so massive and so bright that you can actually see it from Earth with a decent amateur telescope.
Wow, really? So even backyard astronomers can get a glimpse of this distant galaxy.
That's right. It's truly an awe-inspiring sight. This cluster is packed with hundreds of massive, luminous stars, all shining brilliantly together. It's a testament to the sheer scale and power of star formation in a galaxy like Andromeda.
It sounds like a real treat for anyone who can spot it.
It is, and it's a reminder that even though Andromeda is millions of light years away, we can still connect with its wonders through the power of observation and the beauty of the night sky.
It's amazing how something so distant can still feel so close and personal.
It is. It really is.
So we've learned that Andromeda is more than just a collection of stars. It's this complex system with this rich history and a very dynamic future. And speaking of its future, you mentioned earlier that it's on a collision course with our own Milky Way galaxy, the big galactic encounter. I know we've talked about this before on the show, but for our listeners who might be new, can you remind us about the science behind this collision and how can two galaxies even collide?
Well, it all comes down to gravity. Both Andromeda and the Milky Way are hurtling towards each other at a speed of about 300 kilometers per second.
That's incredibly fast.
It is, and over billions of years, that gravitational pull will bring them closer and closer until they eventually merge.
So it's not like two cars crashing head-on. It's more like a slow cosmic dance.
Exactly. The galaxies will actually pass through each other, their stars and gas clouds interacting in complex ways. The gravitational forces will distort their shapes, flinging stars into new orbits, creating tidal tails of gas and dust and triggering bursts of new star formation. It's a process that will unfold over billions of years, gradually transforming both galaxies into a single, larger elliptical galaxy.
Wow, that's just mind-blowing. And what about the supermassive black holes at the centers of each galaxy? What happens to them?
They'll definitely get in on the action, too. Over time, those black holes will spiral towards each other, eventually merging into an even more massive black hole at the center of that newly formed galaxy.
So it's like a cosmic merger of epic proportions. What happens when these black holes finally merge?
It's a process that releases enormous amounts of energy, potentially creating powerful jets of radiation that could be visible across the cosmos.
It's incredible to think about the scale of these events, and it highlights how dynamic and ever-changing the universe truly is. Even galaxies, these seemingly permanent structures, can undergo these dramatic transformations. But what about us? What happens to Earth and our solar system during all of this?
The good news is the chances of our solar system directly colliding with another star system are incredibly slim. The vast distances between stars within a galaxy means that most of it is actually empty space.
So we're not going to get sideswiped by a rogue star.
Not likely. However, we'll definitely feel the effects of the galactic merger. The gravitational forces will disrupt the orbits of stars in both galaxies, potentially flinging our solar system out to a new location within the merged galaxy.
So we might end up with a new cosmic address.
It's certainly a possibility.
And who knows what the night sky would look like from that new vantage point.
Yeah, the combined light of the Milky Way and Andromeda would create a spectacular display, but all the familiar constellations that we know today would be completely rearranged.
It's both exciting and a little unsettling to think about, isn't it?
It really is.
Knowing that the universe is constantly in motion, that even galaxies themselves are not immune to change. But it also underscores the vastness of time and space,
That's right.
and how our place within it all is constantly evolving.
It's a humbling reminder that we are part of something much larger than ourselves, something that's been unfolding for billions of years and will continue to unfold for billions more.
And Andromeda is a fantastic example of that. It's a galaxy teeming with stories of stellar birth and death, galactic mergers, and the powerful forces that shape the universe.
It really is. And, it offers us a glimpse into our own past and our potential future.
It reminds us that there's still so much out there to explore and discover.
There really is.
Well, I think we've covered a lot of ground in this first part of our deep dive into the Andromeda Galaxy. But there's so much more to explore, so join us for part 2, where we'll delve even deeper into Andromeda's mysteries and uncover even more fascinating insights about our incredible galactic neighbor.
Andromeda's story, it's like this tapestry woven with threads of cosmic drama, from the birth and death of stars to the grand ballet of galactic mergers. It's a galaxy that's constantly evolving, shaping, and reshaping itself over eons.
It makes you really appreciate the immense scale of time and the incredible forces that are at play in the universe.
It does. And as we delve deeper into these mysteries that Andromeda holds, we uncover clues not only about its own evolution, but also about the processes that govern the evolution of galaxies in general.
So by studying Andromeda, we're not just learning about one galaxy, but we're gaining insights into the grand cosmic dance of galactic interactions.
Precisely. It's like having a front row seat to this intricate interplay of gravity, matter, and energy that shapes the universe as we know it.
I'm particularly intrigued by Andromeda's history of galactic mergers, and we touched upon it briefly in the first part, but I'd love to hear more about how those collisions have left their mark on the galaxy that we see today.
Well, as we mentioned, Andromeda's entourage of satellite galaxies, they're thought to be remnants of past mergers. These smaller galaxies were drawn in by Andromeda's gravitational pull, and their stars and gas slowly merged with the larger galaxy over billions of years.
So those satellite galaxies were like cosmic crumbs, evidence of Andromeda's galactic feasts.
That's a great way to put it. And by studying the composition and distribution of stars in these satellite galaxies, astronomers can actually piece together a timeline of Andromeda's past mergers. It's much like archaeologists sifting through layers of an ancient city.
It's like a cosmic detective story, uncovering clues from the faint whispers of starlight.
Exactly. And one of the most striking examples of this is the giant stellar stream, known as the Andromeda Giant Stellar Stream.
That sounds intriguing. Tell us more about it.
It's a vast ribbon of stars stretching across hundreds of thousands of light years, arching around Andromeda like a ghostly halo. This stream is thought to be the remnants of a galaxy that was torn apart by Andromeda's gravity billions of years ago.
So it's like a galactic graveyard, the scattered bones of a galaxy long gone.
In a way, yes. And by studying this stellar stream, astronomers can learn about the mass and distribution of dark matter in Andromeda, as well as the dynamics of galactic collisions.
It's amazing how even the destruction of a galaxy can provide valuable insights into the workings of the universe.
It is. And as we uncover more about Andromeda's past mergers, we gain a deeper understanding of the processes that have shaped not only our neighboring galaxy, but also our own Milky Way.
Speaking of our own galaxy, I remember you mentioned that NGC 206, that massive star cluster in Andromeda, is actually visible from Earth with a decent amateur telescope. I'd love to hear more about what makes this cluster so special and how our listeners might be able to spot it in the night sky.
NGC 206 is truly a celestial gem. It's a dazzling collection of hundreds of thousands of stars packed into a relatively small area.
What makes it so much brighter than other star clusters?
Well, for one thing, it's incredibly young, cosmically speaking. Most of its stars formed within the last 100 million years, which means they're still burning hot and bright. And many of these stars are massive, several times larger than our sun, which further amplifies their luminosity.
So it's like a cosmic fireworks display, still sparkling from its recent formation.
A very apt analogy. And to find NGC 206, you'll first need to locate the Andromeda Galaxy itself. On a clear night, away from city lights, it appears as a faint, fuzzy patch of light in the constellation Andromeda.
And once you've found Andromeda, how do you pinpoint NGC 206 within it?
You can use a star chart or a mobile astronomy app to guide you. NGC 206 is located near the edge of Andromeda's disk, appearing as a slightly brighter knot within the galaxy's hazy glow.
It sounds like a rewarding challenge for amateur astronomers, a chance to glimpse a distant star cluster that's been shining for millions of years.
It is, and it's a reminder that even though Andromeda is millions of light years away, we can still connect with its wonders through the power of observation and the beauty of the night sky.
As we continue our exploration of Andromeda, I want to shift our focus now to its ultimate fate, the inevitable collision with our own Milky Way. It's a topic that has sparked both awe and anxiety among astronomers and the public alike. What can you tell us about the science behind this collision and what it means for the future of our galaxy?
Well, the collision between Andromeda and the Milky Way is a celestial event of epic proportions. It's a slow-motion dance of gravity that will unfold over billions of years. As we mentioned earlier, both galaxies are hurtling toward each other at a tremendous speed, drawn together by their mutual gravitational attraction.
As you explained before, it's not like two cars colliding head-on. The galaxies will actually pass through each other, right?
Yes, that's correct. The vast distances between stars mean that direct collisions between individual stars will be extremely rare. However, the gravitational forces will create tidal tails of stars and gas, distort the shapes of both galaxies, and trigger waves of new star formation.
So it's more like a cosmic ballet, a graceful interplay of forces that reshapes the galaxies involved.
Exactly. And as the galaxies continue to interact, their supermassive black holes will eventually spiral towards each other, drawing closer and closer until they finally merge in a cataclysmic event that will send shockwaves throughout the newly formed galaxy.
A cosmic merger of epic proportions. It's hard to even fathom the amount of energy that would be released.
It's truly mind-boggling. But amidst all this cosmic drama, it's important to remember that this collision is billions of years in the future. Our solar system will likely still be around, although its position and view of the night sky will be dramatically altered.
It's a sobering reminder of the vastness of time and the ever-changing nature of the universe. And as we've seen, Andromeda is a galaxy that embodies this concept of change, from its history of galactic mergers to its ongoing evolution.
It's a galaxy that offers us a glimpse into the past, present, and future of our own Milky Way, reminding us that we are part of a grand cosmic story that's still being written.
Well said. And I think that's a perfect point to pause our deep dive into Andromeda for now. Join us for part 3, where we'll explore some of the philosophical implications of these cosmic events and wrap up our journey through the wonders of our galactic neighbor. As we conclude our deep dive into the Andromeda Galaxy, I can't help but feel a sense of awe and wonder at it all.
I know, it's a pretty natural response when you start contemplating the vastness and complexity of the universe, isn't it?
Throughout this journey, we've explored its spiral arms,
Its mysterious double nucleus,
the vibrant stellar nurseries.
and of course, its inevitable collision with our own Milky Way.
It's a galaxy that's both familiar and alien at the same time,
It really is.
offering us this almost like a glimpse into the past, present, and future of our own cosmic home.
That's a good way to put it.
We've discussed this Andromeda story. It's not just about stars, gas, and gravity. It's a story that touches upon some pretty fundamental questions
Like what?
about our place in the universe, the nature of time.
The interconnectedness of all things.
It's almost philosophical, isn't it?
It is.
Here we are on this tiny planet,
Orbiting an average star.
in a galaxy that's just one of billions upon billions of others.
And yet,
We have this capacity to study these distant realms, to unravel their secrets, and to contemplate their ultimate fate.
it really is incredible.
It's a testament to the power of human curiosity, isn't it?
Hmm.
And our innate desire to just understand the world around us.
It really is.
Even though Andromeda is millions of light years away,
Millions of light years away.
we can still connect with its renders.
We can, and it's all through the lens of science.
And the beauty of the night sky.
That's right.
As we've learned, the light that we see from Andromeda
The light that we see.
is traveled for millions of years to reach our eyes,
Millions of years. It's mind-boggling.
carrying with it stories of stellar evolution
Galactic mergers.
and the grand cycles of cosmic creation and destruction.
It's a reminder that we're all part of something much larger than ourselves.
It is.
This cosmic tapestry, it stretches back to the dawn of time.
and will continue to unfold for billions of years to come.
It really is incredible.
Andromeda's story is still being written,
It
and our
is.
own story is intertwined with it.
It is.
As we gaze up at this neighboring galaxy, we're not just observing a distant object, we're witnessing a reflection of our own cosmic journey.
And perhaps that's the most profound lesson that Andromeda teaches us, that even in the vastness of space and the immensity of time, we're all connected to everything around us. We're all part of the same cosmic story, a story that continues to unfold with each passing moment.
It's a beautiful and humbling thought, and I think it's a perfect note to end our deep dive into the Andromeda Galaxy. I want to thank you, our listeners, for joining us on this episode of Cosmos in a Pod, Space and Astronomy series.
We hope you enjoyed exploring the wonders of our galactic neighbor, and that you'll continue to look up at the night sky with a sense of curiosity and awe.
Don't forget to subscribe to Cosmos in a Pod and follow us on our YouTube channel for more explorations of the universe's most fascinating mysteries.
Until next time, keep exploring the cosmos and never stop asking questions.
And remember, the universe is full of stories waiting to be discovered.